Section 1.3, we're looking at page 16. And, use this as an opportunity to ask me questions. I love questions, as you know. So we're solving linear inequalities. And this is the linear inequality that I'm giving you to do. Well, I gave you to do over the weekend, I suppose, and I hope that somebody did this. I didn't notice too many people looking at the videos this particular week prior to this, but let's hope that you found it so easy you didn't need to look at the videos. But this is what the inequality looks like. And the first thing I do is go back and look at the actual problem in the book and make sure I have the exact one. Okay, so that's what it is. And let's solve it. So this is 12x minus 20 positive 5 less than or equal to 16x plus 1. Okay, so all I did so far was to use the distributive property. The same thing you would normally do if you were solving an equation. Then I'm going to combine like terms. So that gives us 12x minus 15 less than or equal to 16x plus 1. Now, as I've said, I am the type of person who likes to bring all the variables to the left and then put the numbers to the right. So negative 16x, negative 16x, that cancels out. You get negative 4x, negative 15, less than or equal to 1. This looks like it's going to come out, very nice. You can add 15 to both sides. You get negative 4x less than or equal to 16. You divide by negative 4. That cancels out. This becomes negative 4. And when you divide by a negative number in an inequality, the inequality sign reverses. So that's a very, very important step. And on the test that's coming up fairly soon, that will be a significant, this will be a question, obviously, on the exam, but this particular step of reversing the inequality will count very, very highly in that problem. Are there any questions? That problem, and this is what we're focusing on now. Let's try to kind of focus on one thing at a time. This is the problem that we're now focusing on. And if there are any questions, that's great. If not, let's move on to this is problem.
About this problem?
I'm sorry, go ahead.
Sorry, I just had a question about the problem.
Sure.
When it comes to the test and things like that, with this problem, are we going to have to, is this like the final answer that we can put, or should we also graph it on a line and also put it?
That's a very good question. Yes, that's a very good question, because in the instructions, it actually indicates that you're not supposed to leave the answer like that. You're supposed to leave the answer in terms of interval notation. Thank you. Very good. So, well, what I like to do is I like to draw a number line and first put it into the number line, right? That's kind of, I feel comfortable doing that. Just put a few values. You don't have to put all the values. But x is greater than or equal to negative 4. So that's a closed-in circle. And we're going to go in this direction. And in terms, so this is the inequality answer. This is the number line answer. And the interval notation answer would be a bracket on the left side. So that's where the negative 4 is. The answer will go all the way out over here to infinity. And that will be an open parentheses. So thank you very, very much Who asked that question?
That'd be me, Talia.
Talia, very good. Don't say that would be me. Tell me what your name is, because I can't speak, okay. Anyway, thank you very much, because you alerted us to something very important. It's not simply doing this, but the question says express in interval notation. So you don't even need the number line. This is what the answer really is right over here. Interval notation. Very good. Thank you. Okay. Next question. Anybody else? You know I love questions, so I will answer as many questions as you would like. Okay, then we're going down to, on the same page, going back up again here, where I have room, page 16, problem 2B. And the question says, m plus 1 is greater than or equal to -3, less than or equal to 3. And again, the first thing I do is go back and look at the problem in the book, make sure I've written it correctly. Okay, as a matter of fact, I think I'm going to draw a line this time and rewrite it. So I have the original, just in case I want to refer back to it. Okay, so the way that we went over this problem in class was to do this. We need to do this to isolate the m. So doing the -1 is very important, and -1 and -1. So I'll let you kind of look at that and digest it. So, normally, if this was the inequality, this would be the step we'd be taking. But actually, it's kind of being put together between two extremes here. So this is the way it's done. This becomes -4. The m is now isolated, just what we were trying to do, and less than or equal. So m is less than or equal to 2 and greater than or equal to -4. But this is just the inequality. So you really should take a look at what this looks like on the number line. This is all you need. You don't have to stop putting numbers all over the place. You should put that out here, it's -infinity, and here it's infinity, but we're not even going to be using that for this particular question, because this is going to be shaded in, this is going to be shaded in, and m is going to be between them. So this is what it looks like on the number line. Was there a question? Somebody sort of sounded like they were coming out with a question. The inequality, the number line, and now the interval notation. Because once again, the solution set is in interval notation. And that's what it'll look like. Otherwise, we will take a look at it together again. So if there are no questions, I'm moving on to page 17, problem F. So I guess that's 2F, really. Okay, so here's the problem. It's 3x plus 2, 3x plus 2 is less than -3. And the key word there is coming up. Or, the key word, or 3x plus 2 is greater than 3. So this was an and situation. M plus 1 is less than or equal to 3, and at the same time, as you can see, greater than or equal to -3. This is an or. Either this could happen or that could happen. And the reason I'm making a distinction is that when it's an and, everything sort of comes together. You see the way there are two parameters here and everything is in the middle? This, we know before we even solve it, is going to be a situation where the two answers go in opposite directions. Okay, so let's solve each one of them first. So let's treat them as two separate problems, -2, -2, 3x is less than -5. Now I got to make sure I got that right because it doesn't look quite right, but you know, that doesn't mean anything. -5/3. Now, students always say, should I change improper fractions to mixed numbers? In this case, I would, because we're going to be putting it on a number line, and we're going to then, you know, be kind of working with it a little. So I would change this to 1 2/3. So x is less than -1 2/3, or, so we're back to the or here, -2, -2, 3x is greater than 1, and x is greater than 1/3. Now, you know, you could look at this and say, you know, what does this mean? But the best way to do a problem of this nature is to actually graph it. That's why I like to do I like to graph a lot, because it gives me a picture of what's happening here. Here's 1, here's 2, and -1 2/3 should be like right around here. It's an open circle, and everything will go in this direction because it's less than -1 2/3. So it's going in this direction, less than 1 2/3. This, and here's 1, here's 2, greater than 1/3. Well, you know, it's very hard to find 1/3 on here, but it looks like it'll be like right over there. And you could put a little line down there to indicate that 1/3 is indeed over there, and it's going to be greater than that. So as I said earlier, the word or is telling us that one of these things is going this way and the other one is going in the opposite direction. The or tells us the solutions are going to go like that. And in terms of interval notation, it will be -∞ to, what was it? -1 2/3. Open parentheses, because it's, you know, there's no line under there. This is not shaded in, therefore that's going to be open parentheses, or 1/3 and infinity. This is what the interval notation will look like. And that's the end of the problem.
Professor, I have a question.
Okay, identify yourself.
Valeria.
Go ahead.
So I see that you put the U. So we put that like U symbol whenever it is or.
Yes.
Like, let's say you just said the -∞, minus -1 2/3. So that would mean or.
Yes. In other words, it's the math. I mean, you know, if somebody took the test and did this, oh, God. If somebody did that, would I give full credit for that? The answer is yes. It's early in the semester. I'm not going to drive people crazy. That's a correct answer as far as I'm concerned, because, you know, you got it right. But, you know, mathematically, we like to be a little mathematical in this class, mainly because it's a mathematics class, you know, but we like to use the U. The concept of a disjunction means that, you know, it's either one or the other. A conjunction, which is the other, you know, symbol that goes like that, is different. But let's not focus on that right now. This is a disjunction. And I got that this is a very common way of doing that. This comes about during logic. When you study logic, they talk about conjunction and disjunction. So the V is acceptable as far as I'm concerned. The U is the most acceptable, but if you put the word or, to go back to Valeria's question, if you used or, I wouldn't be very upset, honestly. But let's try to do things mathematically. That's the answer to your question. Are there any other questions?
If we
Identify yourself. I'd like to know who's speaking. Talia.
Sorry, Talia, yeah. If we forget to do interval notation, will we get points deducted?
Yeah.
Okay.
It's required. If the question says express the answer in interval notation and you don't present the answer in interval notation, I have to say that's partially wrong. Okay. I'm sorry. I hate to, I hate to disappoint students and make them feel bad, but you need to do that if that's what's required. And let's face it, number one, it's required. Number two, it's a very important concept that we will be constantly coming back to throughout the semester, the concept of interval notation. Let me just write that, because that's interval notation. Very, very important concept. Okay, that was chapter section 1.3. Okay. And now we move on to 1.4, and I think I'm going to erase the board. Unless there's a question. If there's a question, it's better to look at it than, if it was erased already. So please, if something's on your mind, let me know. Okay, the homework review now shifts gears to section 1.4. Okay, and the first, and I only give you two problems. And you could see on page 22, problems B and D. These are the only problems I gave you in the entire chapter. And the reason is that each of the two problems, if you could look at them in your workbook, but let me just write them over here, are different in a very nice way, a very special way that I'll be describing to you in just a moment. Okay, so those are the two problems. And you'll notice that one of the problems is a greater than, and one of the problems is a less than. First of all, let's identify section 1.4 as solving absolute value inequalities. So we're combining absolute values with inequalities, and we're trying to solve that type of problem. One of them is a greater than. That's going to wind up being an or situation, where the two solutions are going in opposite directions. This less than implies that it's an and situation where the two solutions come together. Now, that'll become much more clear to you in a few minutes as we now do these problems. So this, now remember the generalization that we did. I don't even remember the last time we met, on Thursday, last Thursday, right? And we did that from here, you go in two directions. You either say x plus 4 is greater than or equal to 12, or, the big or, x plus 4 is less than or equal to negative 12. This is a very, very key step. When it's greater than, it's going to be one of them greater than 12, one of them less than 12. So that was the generalization that if the absolute value of x is greater than or equal to a, then x is greater than or equal to a, or x is less than or equal to negative a. This is the rule right here for this particular problem. We did this on Thursday. So, and that's what I did. This whole thing started out as the absolute value greater than 12. Therefore, one of them is greater than 12. There it is. And the other one is less than or equal to negative 12. And now let's solve them. And I've kind of pinned myself by writing this rule over here, which is kind of important. So I'm glad I did it. But x plus 4 is greater than or equal to 12, and negative 4, so x is greater than or equal to 8. That's one of them. And the other one, x plus 4, is greater than or equal to negative 12, negative 4, x is greater than or equal to negative 16. These are the two solutions. Now, again, if you try to picture this without drawing a diagram, it's difficult. It's difficult to picture this without, kind of diagramming it. And that's why I like to draw the number lines. So let me not forget the infinities and the 0 in the middle, and the 8 on one side, and the negative 16 on the other side. Okay, and we need x is greater than or equal to 8. So that'll be here going in this direction. X is really.
Oh, but you flipped the sign.
Yeah, I accidentally flipped the sign for no reason whatsoever. Okay, so that was a mistake because this was greater than 12. This should have been less than or equal to 16. Okay, not greater than negative 16, less than 16. One of them is greater than, the other one is less than. I've somehow flipped this around from less than to greater than for absolutely no reason. So keep it. Keep the sign, unless you're multiplying or dividing by a negative number. But in general, keep the sign, and this would look like this. Okay, so now you can understand what's happening. The fact that it's a greater than means that the solutions go in opposite directions. That's the important thing to remember in this problem. And in interval notation, it's negative infinity to negative 16, which is in brackets, because there's a line underneath. This is shaded in, that's negative 6. So that's one possibility. And then, because they're going in opposite directions, they can't happen at the same time. So it's or 8 is to infinity. And this is the answer to the question. So we move on to the next one. And if it's less than, then that will mean that 4x plus 12 is less than 8, and this less than sign implies that it's going to be an and 4x plus 12 is greater than negative 8. And let's solve them. So this comes from the rule which states that the absolute value of x is less than or equal to a, therefore x is less than a, and x is greater than negative a. So these are the two rules, this one and the one over here that's boxed. This was an or, this is an and. Those are the two situations. -12, -12, 4x is less than -4, divide by 4, x is less than -1, and (4x greater than -20 divided by 4), x is greater than -5. Greater than -5, less than -1. Again, it's hard to visualize these things, so we draw a number line. And we're talking about all negatives, so we could sort of move the negatives over here. -1, -2, -3, -4, -5. So x has to be greater than -5, open circle, and less than -1. So it's going to be between the two. Okay, that's an and situation when it's between, an or situation when it's away from each other. And x is going, well, we did that already. Let's move now to interval notation, where we're going to have the -5 on one side and the -1 on the other. This is the answer. So, this is the greater than -5, the -5 goes there, the less than -1, the -1 goes there. And that was the homework.